For our next example, we have x minus 2 over 3, the absolute value, is less than 4. So are the bars isolated? And yes, they certainly are. Even though there's a fraction in there, it's okay, the bars are still isolated. Then I look at this and determine, is this a less than which or a greater? So this is a less than which. Again, the 4 is positive, and the 4 needs to be positive in order for this to work. We'll explore when c is negative in the next part. So because it's a positive 4 and it's a less than which, we have x minus 2 over 3 is sandwiched between positive 4 and negative 4. Now I need to solve for x. So I need to get rid of the divide by 3 and get rid of the multiply or subtract 2. So the thing I'm going to do first is I'm going to multiply all three sides by 3. The reason I do that is so that these 3's divide out nicely, and I'm just left with the numerator x minus 2. And then I have to get rid of the minus 2, so I do the opposite, which is add 2. Whatever I do to one side, I do to all three sides, which leaves me with x is less than 14, and on the lower side, negative 10. So negative 10 is less than x, which is less than 14. So we have open circles on both, and a less than, which means you have the values in between. So my interval notation answer is negative 10 to 14, both parentheses. Again, that's not an ordered pair, it's an interval because we're talking about intervals in this problem. On the next problem, notice that the number on the right-hand side is negative. We have a negative 1, and it might seem like that's not part of this category where c is positive. But remember, the first rule is always to get my bars isolated. So here are my bars right here. And notice there's a minus 4 here. That means they're not isolated right now. So I'm going to add 4 to both sides first to get my bars isolated. So I have 1 minus 2x, the absolute value, is still greater than or equal to, because I didn't multiply or divide by negative, so I don't switch my signs, positive 3. Now at this point, now I need to look at my 3. Is this positive? Well, yes, this is positive, so I can keep going. Then I have to decide, is this a less than which or a greater? So because my inequality is a greater than symbol, I know that this is a greater problem. So because it's a greater, I'm going to use my or symbol, and I'm going to break this up into two inequalities without any absolute value symbols. The one on the right, I like to just leave the same, just without bars. The inequality sign and the sign of the 3 stay the same. And on the other side, the expression comes out of the bars and two signs are changed. My inequality changes to less than or equal to, and my positive 3 changes to negative 3. At this point, I can solve each of these independently. So I have negative 2x is less than or equal to negative 4. And on the other side, I have negative 2x is greater than or equal to 2. On each of these inequalities, I'm going to divide both sides by negative 2, which leaves me with x is greater than or equal to, because I'm dividing by negative, I have to switch my sign, and that's positive 2. So at positive 2, I have a closed circle, and it goes to the right. On the other inequality, I divide both sides by negative 2, and I'm getting x is less than or equal to. I switch my sign, because whenever you multiply or divide by negative, you switch your sign, negative 1. Again, I have a closed circle, and it goes to the left because x is less than. So my inequality answer is negative infinity to negative 1 union 2 to infinity. Notice that the negative 1 and the 2 get brackets because they're closed circles, and the infinities always get parentheses. Now I want you to notice that all of the examples that we have just done have our c, the number on the right hand side of the inequality, being positive. This 3 was positive, Okay, even though it was negative up here, when the bars were isolated, it was positive, and over here it was positive 4. On the other examples, we all had positive numbers. So when we have positive numbers, you're looking for less thanwiches or greators, and then you'll get a unique solution. Next, we're going to explore when C is negative. So if I go and think about the same exploration activity we did before, if I take the absolute value of some number, is that ever going to be less than negative 2? Well, what values work here? If I say, let's say 0, is the absolute value of 0, which is 0, is that less than 2? No. What if I take 1? The absolute value is 1 is 1. Is that less than negative 2? No. What if I do something negative, like negative 5? The absolute value of negative 5 is positive 5. If positive 5 ever less than negative 2? Well, no, it doesn't seem like any of these are going to work. So let's think about this. Whenever I take the absolute value of some number, that means the answer is going to be either positive or 0. Do you agree with that? Whatever you plug in the absolute value, it's either going to be positive or 0. Can positive or 0 things ever be less than negative? Oh, no, they can't. So nothing on the number line is working here at all. So what is my solution? No solution, which is similar to when we had the absolute value equations. But let's take a look at the next one. What value works when I plug the absolute value in that is greater than negative 2? Well, how about 0? Is the absolute value of 0, which is 0, greater than negative 2? Sure, that one works. How about 4? Is the absolute value of 4 greater than negative 2? Yeah, that works. How about negative 2 or negative 3? The absolute value of negative 3, is that greater than negative 2? Well, yeah, when you take the absolute value, you get things that are positive or 0, right? So let's think about this. Whenever you take the absolute value of an x, you get positive or 0. You're getting positive or 0 things. Is that always or never greater than negative 2? Well, positive things are always bigger, right? So it doesn't matter what value you have, positive or 0 things are always greater than negative 2. So in this case, you have all of the solutions in the world, which is very different from the last time we had an absolute value with a negative. So if it's less than, you get no solutions. If it's greater than a negative, you get all solutions. To summarize that, if you have the absolute value is less than C, where C is negative, then the solution is no solution. If the absolute value of C is greater than C, again, C is negative, then the solution is all real solutions, which we write in interval notation negative infinity to positive infinity. So let's look at this first problem. This is the absolute value. Is it isolated? Check. First thing is to isolate the absolute value bars. Next, we want to identify if this is positive or 0. Is this positive or 0? Well, no, it's negative. So because it's negative, I have either the solution all real solutions or no real solution. For me, this was a hard thing for me to memorize, and so what I did instead is I said, whenever I take the absolute value, I know I get positive things or 0 things. And then I just compare it to the right-hand side. Are positive things or 0 things less than negative ever? Can positive things ever be less than negative 8? Well, no. So the answer is no solution. You could also just memorize if it's less than, it's going to be no solution. Next problem. Are the absolute value bars all by themselves? Yes, they are. Next thing I ask, is this positive or 0? Well, no, it's negative, isn't it? So because it's negative, I know my answer is going to be all real solutions or no real solutions. I just got to figure out which one. So you can just memorize it, or if you want to logic your way through it, you know whenever you take the absolute value of something, it's either positive or 0, correct? So then I compare this statement. Is positive or 0 things always or never greater than or equal to negative 8? Are positive things always greater than negative 8 or never greater than negative? Well, positive things are always bigger than negative, right? So this is a yes. This is yes, this is true. So because this is true, my answer is all real solutions. And the way we write that is negative infinity to positive infinity. Now this one may seem like it's not one of these negative cases, but because the 5 is negative, but you have to remember that you have to isolate your bars first. So I need to subtract 9 from both sides, and then I need to divide both sides by 4 before I decide if this is negative or positive. Okay, so my question here is this positive or 0? Well, no, it's not. It's negative. Okay, so since it's negative, I either have one of two solutions. All real solutions or no real solution. You could just memorize less than is no solution, but I have a hard time memorizing that one. So if I think about this absolute value bar as being something positive or 0, I don't even care what's inside of it. I just know that whenever it comes out of the bars, it will be positive or 0. Is that always going to be less than -1 or never going to be less than -1? And I think the answer there is it's never going to be less than -1, so my answer is no solution. Or you could just memorize this as well.